Okay, in this lesson we're going to start chapter 7. We don't do all of chapter 7, we just do some basic stuff in it. And the first section is basic integration approaches, which is important because it's going to review some of the things you've learned and show you how they can trick you by making them all look very similar, but you have to see the subtle differences. So I'm going to give you 4 examples. So I'll start with A, and it is going to be the integral of 4 over x squared plus 9 dx. And then I'm going to give you B, which is going to be the integral of 4x over x squared plus 9. That'll look a little better. Not used to writing. And then C is the integral of 4x squared over x squared plus 9 dx. Notice they all have the same, oops, I messed up. The first one was supposed to be x squared plus 9. They're all supposed to have the same denominator. And then the last one, part D, is a combination. It's actually 2 of them put together. So I have 4x plus 4 over x squared plus 9. And they all look like the same problem to you, but they are very different. And the trick here is to realize they are similar, but they require different approaches. So if you look at B, B's the easiest one. B is a U sub. This is a U sub problem. How do I know it's a U sub? I know it's a U sub because I look right here, I look at the denominator, and its derivative is 2x. And 4x is just a coefficient away from being 2x. So I know that's going to be a U sub. So for part B, if we're going to do part B, we're going to just do our off to the side over here. We're going to say that U is equal to x squared plus 9. That means that du is equal to 2x dx. And I look over there, and just to make it easy on myself, I'm going to put a 1/2 du equals x dx. So what I do is for this one I go, okay, this equals, and I'm going to pull the 4 out in front, integral. And then, so instead of the x dx, I'm going to put a 1/2 x dx. So I pull the 1/2 in front, and just ends up being 4 over 2. So that's my half. And then instead of x dx right here, so this is going to be the 1/2 du, and this is u. So the 1/2 goes with the 4, and then I end up with 1 over u du. And the integral of that, so I end up with 2, and the 1 over u du is natural log absolute value of the x squared plus 9 plus c. And you don't actually have to put the absolute values because x squared plus 9 is always positive, but if you put them, then when it's something that can be negative, you won't forget to put them down. So I always put them on. Alright, so that one was straightforward. And now A, you should also recognize because we've done inverse trig. And if you look at this real quick, you know it's inverse trig because if you look at B where the denominator is u, on A, the derivative is not up top. There is no x. And so I look right there and I go, no x. No x. Since there's no x, it must be inverse trig. And you look at it, and what trig function does it look like? Because it's an x squared plus an a squared. So this has to be inverse tangent. So I look over here and I go, okay, from this, I know that my a is equal to 3, and my u is equal to x, and since u equals x, du equal dx, I don't have to play any games. That's awesome. So I just come to this one and I go, okay, well, that means it's going to be 4. I pull the 4 out, because it's just 4 times 1 over. And then I go, alright, well, my a is 3, and I know for inverse trig that I have to go 1 over a, so I'm divided by 3, and then it's going to be tangent inverse of whatever my u is. In this case, my u is going to be, goes back to the x, over a, which is 3, and then it's going to be plus c. And then we look at C. Actually, let's go, well, yeah, let's go to D, because D is the combination. Is D both A and B? Yep, that's what D is. So let's do D, it's an easy one, and then we'll pull C out and we'll do C down below, because C is going to take a little more room. So for D, can we break D apart? Can we take that fraction, we break it apart? Been trying to get y'all to do this all year. So you're going to take the first part, and you're going to divide it by the denominator. And then you're going to break it apart and do the second part divided by the denominator. And you're going to end up with the integral of 4x over x squared plus 9 dx plus the integral of 4 over x squared plus 9 dx. And what's that give you? It gives you your first, gives you b, where the answer was 2 natural log absolute value x squared plus 9 plus, plus, and the second one was, it's going to be the 4/3 tangent inverse of x over 3, and then it's all plus c. And then that leaves us with c. So we're going to come down here to c. And c is a little tricky, because you'll notice that the order of the denominator and the numerator are the same. And any time that the numerator has the same order or higher order than the denominator, you're going to want to do long division. So what we do is, before we start on C, we're going to go, okay, I have 4x squared, and I'm going to divide it by x squared plus 9. You can do synthetic division, but I'm not going there because y'all can barely remember anything from last year. And you should have, I think you should have seen Algebra 2, I can't remember. Alright, so I'm looking at this go, I got an x squared, I got a 4x squared, that means I have to multiply by 4. So that means I have 4x squared plus 36. Let me rewrite that so you can actually see it. Alright, so that whole thing is going to be subtracted. So the 4x squareds cancel out. If they don't cancel out, you've done something wrong. And you got nothing up here, so it's 0 minus 36. So you're going to end up with a minus 36. That's going to be your remainder. This is the remainder. That means that 4x squared over x squared plus 9 is equal to the 4 plus, actually since it's negative, it's minus 36 over x squared plus 9. Now, the first part is just integrating 4. The second part is an inverse tangent, like in A. So what C becomes, the integral of 4x squared over x squared plus 9 dx is going to equal to the integral of 4 dx minus the integral, I'm going to put the 36 out in front, it's 1 over x squared plus 9 dx. And you're going to look at this and go, oh, it's inverse trig. My A is equal to 3, u is equal to x, du equals dx. And I go, okay, well that's easy. So that means that the integral of 4x squared over x squared plus 9 dx is equal to, the integral of 4 is 4x. The integral of 1 over x squared plus 9 is an inverse tangent, so it's going to be minus the 36 divided by a, which is the 3, and then you're going to have a tangent inverse, and my u is x, and my a is 3, and then it's plus c, and I can simplify the 36 over 3, that just becomes 12. That becomes 12. So it ends up by being 4x minus 12 tangent inverse plus c. Okay. Normally, that's what I would do in one day, because it would be right at, we would be starting back. But since we've missed so much time, I'm going to keep going. I'm going to give you the next one. Oh, why didn't that work? I should have. Ooh, that's no fun. Okay, let's get rid of those. Okay, just give me a moment while I get us settled. I thought I made a template, but apparently I did not. I'm not going to worry about it. Make a template. Oh, come on. Oh, there it is. I want T. Yep. Save. All right. So let's see if this is going to work. Yeah, all right. There we go. We're much better off. All right, here we go. So for our next trick, we're going to remember how to complete the square. And the reason we're going to learn to complete the square again is because you'll notice that on the inverse trig they were always polynomials. I mean, not polynomials, they're quadratics. They're always x squared plus a squared, or x squared minus a squared, or a squared minus x squared. So if you can complete the square, then we can do something when we've shifted, so we've shifted those functions off of the origin. So we're going to start off, just look at the basic technique. So one of the first things we want to do is, so we want x squared. We always want the coefficient a. So you know how it's a, well, let me write it out. Okay, basic standard form for a quadratic is ax squared plus bx plus c. That's standard form. But we don't want an a. This has to be 1. So the first thing you always do is divide by a if a is anything but 1. We want the x squared's coefficient to be 1. It has to be 1. And then, so moving on, so you would do that, and then this would become our b. So we always want 1x squared, we want a bx plus c. So this is our new form, where that b comes from the b over a. But anyway, it's some number b. And then what you're doing is you take this b and you divide it by 2. And then we're going to use it twice. Always twice. So this is going to equal, and we're going to go, okay, it's going to be x squared plus bx plus, and then I'm going to take, let me write that in black. We're going to complete the square. We're going to make it a perfect square by taking this b over a and squaring it. B over c, sorry, b over 2. I can't talk. There, we're squaring it. But the problem is, if we add that in order to keep this to be the same polynomial, we have to go, okay, so we have outside, we have plus c. We left the plus c outside because we're taking these two terms and we're completing the square here. Leave the c alone, but in order to balance it, we have to subtract out a b minus 2 squared. These two have to match. You have to balance out. If you're going to add it, you have to subtract it. Now, a lot of times in Algebra 2, you're taught to add it to the other side of the equation. The problem is when we're doing this in calculus, we don't have another side of the equation. We are changing an expression, so we have to leave it all in one thing. All right, so that's the first thing you're going to do. The second thing you're going to do is, once you've done this, you don't have to factor that quadratic. You already have it factored. This whole thing is going to become, that is going to become x, and then you take the, it's going to be plus the b. You know, let me do this in blue, since I've been using blue, maybe. Come on, baby. Don't go out on me. Okay, I'm going to change batteries real quick, because I think that's the problem with my pen's gotten out of a battery. So just add another one. Yes, I'm in the middle of a video. I'm almost finished. So let me finish, okay? Okay, so we take this and we put in the b minus 2 right here. So we're using it twice. We use it once to complete the square, and once it becomes the factor. So then we have plus c minus b over 2 squared. And when you do this, if this was an inverse trig, the x plus b over 2, all that squared would be the u squared, and the c minus b over 2 squared would be the a squared. So let me show you how this works. Now that we can complete the square, hopefully, I'm going to give you example 1. For example 1, we are going to integrate 1 over x squared plus 4x plus 13. And you look at it first, you want to say, does it do u sub? Well, it doesn't do, it can't be u sub, because if the denominator is u, the numerator does not have a 2x plus 4 in it. So it can't be u sub. So then you look at it and go like, oh no, it's a quadratic. If it's a quadratic, it's got to be inverse tangent, because there's no square root. So I need something, I need to convert this to something that's the integral of 1 over something squared plus something else squared, or something, at least some other number. And so that's what we're going to complete the square. We're going to go x squared. Notice my coefficient is 1, so that's good. And then it's plus 4x plus 13. That's got to equal x squared plus 4x. I'm going to complete the square, and then I'll put the 13 side. And then I look at that, and my b is 4, so b over 2 is 4 over 2, which equals 2. That means that this is going to be plus 2 squared, which is 4, right? So I have to subtract a 4 on the outside. Added a 4, subtracted a 4. I also know that this factor is going to be x plus 2 squared, because I use this 2 there also. And then 13 minus 4 is plus 9, so I get x squared, x 2 squared plus 9. If I'm going to integrate that, I have the integral. That becomes the integral of 1 over x plus 2 squared plus 9. That means that a is equal to 3 and u is equal to x plus 2. That means du dx, and I'm in business. So this whole thing has to equal 1 over a, which is 1/3, tangent inverse of my u, which is x plus 2, over my a, which is 3, plus c. And we can do these also for inverse sine and inverse secant, but more than likely it's going to be inverse sine. And what I'm going to do is I'm going to stop this video now, and then in the next video I will show you how to do it if it's inverse sine, and I will give you another tricky one.